let me start the stream. There we go. All right. Good afternoon, Jan.
Hey, Michael. Good morning. How are you?
I'm doing well. Yeah, uh, I've been playing around with a lot of cool stuff. So yeah, having a good time with that. Which means that I did not get to the identity stuff that I was meaning to get to this week. But
Mm.
uh, but yeah, I have other things to share. So we
Okay,
can we can
let's hear
we
about
can
that.
talk about that. But before we jump into that, I do want to yeah, to kind of circle back. I've been spending a lot of time on Jinaga and building the demo that I want to do. I haven't checked in with you on DWS in a while. um,
Well, I haven't made any progress for the moment. I haven't made any progress. Not that it's not working,
mhm.
but I've been so busy with other things. Um,
Yeah, I can't remember
and
where did we leave off? What was the next step?
we were on still the same form.
Hmm.
Um, I was looking at the combo boxes because you made the combo boxes,
Mm-hmm.
but then I say, yeah, we still need that or we still need that. Um, I've been looking into it and then I got no further.
Okay.
And left and right, I do have an hour. Then I say, okay, let's see for when I have a little bit more time. And every time I think next week I will have more time, but
Mm-hmm.
so far, um,
Okay. Well, yeah. So maybe the stuff that I've been researching will give you a tool that you can use to help out with. So I've been working on this idea of somebody with Excel skills should be able to build an application using Jinaga. They should be.
mm,
It shouldn't take you know too many skills. Uh, yeah, I want to drive the need for specific expertise
mm,
down to that level. Um, so yeah, I think AI is going to be a part of that solution. And so
yeah,
yeah, I've been playing around with ChatGPT to see if I can get that to be a
mm.
domain modeling expert. But yeah, of course, this week there's
There
a
was
brand new one
there
in
was
town.
DeepScan,
Yeah,
DeepScan,
DeepSeek.
no,
DeepSeek.
oh, DeepSeek, yeah,
Yes. Yeah.
DeepScan.
So yeah, I've done some experimentation with DeepSeek, and um, yeah, so far I'll cut right to the chase. So far, not yeah, it's still not there, but it's a new tool, so yeah, so
Hmm.
we can try things out. Um, so so yeah, I have DeepSeek running on my MacBook Pro because that's got the neural engine built in, so it can run a pretty good sized model. So yeah, on the Zoom, I'm sharing from the MacBook Pro, so we should be able to kind of walk through what that looks like, where we are, maybe try a few experiments.
Okay,
Yeah. All right. So
and you're
first,
not trying to torture the artificial intelligence.
no, I want it to work for me.
Uh,
So um, let's
yeah.
switch
No,
to.
I read some head titles, but I don't know what they wanted to do exactly. But it said like scientists want to torture an uh, artificial intelligence.
Yeah, I'm not too happy with the mainstream coverage of AI, especially around DeepSeek. Um, yeah, I think that there's a lot too much of that emotional language it's used
Mm.
to get people to click on articles, and yeah, it could be that what the article really means is that they want to stress test it. They want to you know check test the boundaries.
I didn't
Yeah,
read it.
yeah. So
Mhm.
so yeah, yeah, there's that kind of thing, and then there's also recently there's been a report that OpenAI has discovered um, evidence that DeepSeek was trained on its model.
Mm.
And if you look at how DeepSeek, it's how it was trained is described in a paper, and there's some source code that so this is an open weight model. It's also an open source to some degree model, um, and so you can see how it was trained, and the whole idea um, was start with a big model and uh, create smaller models that are trained on their output so uh, they can do the same thing in fewer weights. That's that's the whole the whole purpose. And so it's not that OpenAI did some sleuthing and found this evidence. It's like, no, that's literally what they said they did. That is what they did. Um, and so and that's the whole idea of this AI research is you're supposed to be building on top of other people's research. That's the reason that OpenAI is called OpenAI, is that that's how they started. They've switched to something that's completely closed, but they started as open AI research, and we're going to publish all of our results. Um, so, so yeah, it's a weird thing that the way that it's being covered. Um, so, the tool that I'm going to use
Well,
to
technology with sensation and
yeah,
with politics, and then you get something.
imagine that. That's the world we live
Something
in.
not too intelligent, I think.
That is
Uh,
true. Um, okay, so the tool that I'm using, oh, Llama. Um, this is the tool that I'm using in order to run open weight models on my machine. So, um, as opposed to using an interface like ChatGPT or like the DeepSeek app that you can download on your phone, this is running the model entirely on your machine. Um,
okay.
and the way that you can obtain these models is you can download them through Ollama. Um, oops. Ollama. I forgot to type the command list. So you can download them through Ollama, and you can um, then run them and it's through this command line, and you can see the models that I've already downloaded.
Mm.
Yeah, some of them I've been playing around with for a few weeks, and yeah, uh, some just recently. So
Mhm.
um, yeah, I've currently got Llama 3 on there. There's a 3.3 now that is a newer version of that model. It's got more weights though, so it takes up more memory. So you can see the amount of memory that each one of these takes. Um, so yeah, Llama 3 is 4.7 gigabytes.
Mm.
But yeah, there's other ones that have been trying like Phi 4. Um, and then this here, we've got two versions of DeepSeek, DeepSeek R1. So yeah, the 4.7 gigabyte model, that
Mhm.
is 7 billion parameters. So that's the 7B, which is the smallest. I think that's the smallest. There might be, yeah. Let's go with that. That's the smallest. Yeah, certainly the smallest one that you would want to run. So you can play around with that, and then here I've got the 32 billion parameter model, which takes up 19 gigabytes. So um,
Mm.
so yeah, you can see um, the more parameters that you've got, more memory it takes, um, and the more parameters also means that it runs more slowly, but it also means better results on average.
Yeah.
So in order to run one of these, we say llama run, and so I'm going to run deep. Well, let's start with something nice and small like llama 3, and then we've got our message prompt. So yeah, tell me about historical modeling, and then it's basically going to use whatever was in its training data set to try to answer that question.
Even doesn't mind about the spelling. You type two I's.
Ah, yeah.
he knows what he has to say.
Yep. So, so yeah, you can if you, yeah, it generates some very reasonable text. But
Mm.
uh, if you kind of parse the text, you can realize, okay, it's not constraining itself to my definition of historical modeling. Yeah,
Mm.
it's making something up, or maybe there really is something out there in the world um, that uses the term historical modeling to mean this. Um, but but yeah, this is not quite uh, constrained, refined to what it is that I want to talk about. Powerful research methodology that can provide valuable insights into complex systems and phenomenon by simulating and
If you,
analyzing past events.
and if you add to the question as used in Jinaga,
Ah, yes. Oracle modeling as used in the Jinaga framework. Question mark. A specific approach representing reasoning about temporal knowledge using graphical models. Okay, that's better. All right. Understand causality and consequences.
yeah.
Make informed decisions. Anticipate future scenarios. Uh, use learned patterns and trends to predict plausible future outcomes. Cool.
Mm.
Not what it does. um, In summary, a historical modeling component enables a framework to represent and reason about complex temporal knowledge by constructing hierarchical graphical models that capture event relationships. That part is close. I would,
Mm.
yeah, if somebody walked up to me and said that, I would nod my head and say, yeah. Causal dependencies, temporal information. Yeah, and then that next sentence is not quite right. Analyze dynamic situations, understand causality and consequences, make informed decisions, and anticipate future scenarios. I think Jinaga plus AI can get there. And by AI, I'm opening up to ML as well, not just language models, but um, you know, train a model based on the history that you've gathered in your historical model, and then uh, you can make predictions. Okay, so far, bye. Um, so far, it's not constrained to what I'm specifically talking about. Let's also try DeepSeek R1. We'll just do the small one. So this will be nice and fast. So tell me about historical modeling. So we'll give it the first one that didn't have very much context. So so there are a few interesting things about DeepSeek. It's what they call a reasoning model. I guess that's what the R in R1 stands for. Um, DeepSeek is actually the organization that created these models. So you know, so you can see it started think and then it ended think, and so it's first of all kind of talking itself through answering the question, putting all of that into context before it starts to generate the answer, which means it takes a little bit longer. If you're using ChatGPT, you can use O1 and achieve similar results. But let's see how well it did. So first of all, what was it thinking about? Yeah, I want to understand historical modeling better. Okay, so let me try to break this down. Yeah, so first off, another point I also remember, but I'm not entirely sure. So you can see these these kind of phrases that it kind of bounces back and forth in its understanding. By the way, there was a complex reasoning problem that I gave it where it kept on going back in a circle. It said, oh, but wait, oh, but let me consider this. Oh, but that was kind of funny. Maybe I'll walk through that one too. Yeah, I think one of the purposes is to analyze past trends, but I'm not entirely sure. Then there's the part about uncertainty and projections. Um, yeah, another thing concerned is the time period being modeled. So yeah, it's got that the general words historical modeling, and so it made something up that is leveraging historical data to understand past events, explore trends, and make informed projections about the future. Which, given the fact that two models came up with that definition of historical modeling, maybe that really is one of
There
the
must
uses
be
of that
something.
term. Yeah.
Yeah,
Um,
but if I see that text, I
yeah.
think about going to an exam and not having studied too well, having read some words left and right, and then trying to make up an answer.
Yeah.
Um,
I know that Jinaga is a framework related to machine learning. No, it's not. Okay. Uh, so
that
it's
word
trying to do machine
forecast.
learning on historical data using Jinaga. That's, well, it probably, because it had the previous question and answer in context, it probably made up a Jinaga framework that was related to that.
Hmm.
Kind of makes sense. Um, so uh, so now let's get more specific and see if my book is in the training set. So uh, tell me about the art of immutable architecture by Michael L. Perry. All right, I know that Michael L. Perry is an author who writes about software architecture. Okay. Not familiar with that specific book. Interesting. So the art of implies, oh, this is interesting. What does it say? It's more of an art form than a set of principles and practices. Uh oh. Okay. Yeah, one of my
It was
friends, when I said, "Oh, this is the title that I've chosen for my book, The Art of," and he's like, "You sure you've earned that? That's pretentious." um, well, it is an art form. It's balance between
mm,
art and science, but yeah, mostly science and math. But
there's nothing about mathematics.
yeah, that's true.
Hmm.
Yeah. Yeah, so some of the art of immutable architectures explores principles and practices behind building software systems in fixed configurations after deployment, which is immutable infrastructure. So I can see where it got that, covering aspects like code optimization, data models, scalability, separation concerns, and possibly DevOps practices. So some of those first things, nothing about DevOps, but DevOps is um, is immutable infrastructure. Yeah,
Hmm.
that's part of a DevOps. So it's
But
yeah, guessed some
but
things.
how could it know about your book? Because I don't think it's. I hope it's not available on the web as PDF. Um,
Yeah, yeah, maybe. Yeah, that's the that's the challenge with these models is that they don't often reveal exactly what training data they used. So
mm,
so yeah, people will ask specific things in order to try to tease out what was in the training data. Like yeah, famously the Mid Journey, I think it was, or maybe it was Dolly. Uh, if you, at least in the earlier versions, if you asked for, describe a scene that you've already got your iStock photo image for, it'll basically render that scene with iStock photo as you never said, iStock photo in the prompt, but it's right there in the image. Um, I think they've since fixed that, but it's like, oh yeah, caught you were trained on the stock images that were available for free. Um,
mm.
so yeah, nobody got paid for that training set. Um, okay, so uh, yeah, we can see that let's go by that it doesn't really have the context that we want.
But
So
can you give these tools? For example, if you would say the PDF of your book,
mm-hmm.
can you input it?
Yes, you
Because,
can.
because because then it becomes much more helpful. And then can you limit that knowledge to your session,
That's the challenge. Yeah. So
or is it taking away your book and Because a next person could
Oh,
say, what is inside the book of Michael? What is inside Michael's book? And it gives it the whole
yeah.
text, and then the copyright is gone.
Yeah. Um, yeah, so that is not an issue the way that these models are currently used, um, and that the the information that is built up in one session is not available to the next. So if you go to ChatGPT and you ask,
Mm,
what did the last person talk about? Um, yeah, it doesn't even have that information.
mm,
It'll probably tell you that if you ask that. I don't think I've actually asked that question, but yeah, these are constrained to just the information that is gleaned during that session. Now, if you use an online model, then the company who runs that model may, and in fact, OpenAI says they do, they may gather all of that information about your prompts and the responses, and
mm,
use that information to train the next version of the model. That was the whole reason for ChatGPT in the first place, is
mm,
to get that out there in front of people so that we can first of all collect their thumbs up, thumbs down to see if it's doing a good job and
mm,
train the model that way. But then also use how they continue the conversation as part of the training set. So if they ask for further clarification, okay, we know that response was not very good. If they build on it, they know that response is good. If they just stop the conversation, then the response probably wasn't all that good, or they got exactly what they were asking for. That was one of the reasons, by the way,
mm,
that I started out by thanking the model for giving me a good answer. It's like, okay, now in addition to the thumbs up, you've got that. So go off and train the next one and do better next time. But running offline like this, you know that you're not giving the organization that chance. This information never leaves my computer. So,
mm.
so there is that control. What I've got here is now this one is 5.4. Let me go ahead and
So
there's
you could import the whole book
there's the one.
into the model.
Yes, based on its context window, and
Mm,
these larger models tend to also have larger context windows. You can preload it with some context that you want it to understand and know about um, before it starts answering the questions. Um, so here, I've given it a system prompt that tells it it knows about my book and knows about the Jinaga framework, and then a little uh, a little blurb about what the upcoming conversation is going to be about, and then uh, I've got the entire contents of chapter 4
mm.
of the second edition. So chapter
Okay.
4 in the second edition is analysis, because I want this thing to have in mind the uh, the analysis techniques in this chapter.
So there we go, feeding it with
Mm-hmm.
with part of the book.
Yep. Yep. And so I wrote the book in Markdown, so I just simply took the
Mm,
Markdown files and said, here you go. Here's all of chapter 4. I even kept in the diagrams. So, um, little graph viz
mm,
diagrams. Um, they get a lot more complicated. Like this one is doing an instance diagram, so I want actual tables in there. Um, so, uh, so my hope is that it will even learn how to write these diagrams. So, um, so then I can put this text tool behind an interface that when it sees, uh, triple tick come across the line, it says, okay, this must be a
mm.
diagram. Let me go ahead and launch launch GraphViz to render this, and then put that image in line. So what I've done here is this looks a lot like a Docker file. So from some base model. So here we're using the model DeepSeek R1, the 32 billion parameter version. Here's the system prompt. So triple quotes means multi-line. And so the end after all of this stuff gets you to the end of chapter 4 and then triple quotes at the end. So it says, all right, this is all in context. And then I ran a command, Ollama create, that created a model based on that model file. So the model file, you can see it's named model file dash modeler dash DeepSeek. And that's actually the name of the model that I told it to create. So now you can do an Ollama run modeler DeepSeek. And so now it's running DeepSeek with that system prompt. So now if I say, tell me about historical modeling, now it's got that context. And so it should give me more accurate information. Oh, it didn't have to think at all. Imagine that. Oh, goodness. It's not using the context. Wow, that's a fail. All right, Control C. Tell me about the book, The Art of Immutable Architecture.
It tells you, I throw it away without reading.
Oh, that looks hard.
Yeah. That would mean that it's not intelligent at all. If it throws away your book without reading.
Yeah, I like that. That's okay. So now it's actually thinking. All right, I'm trying to understand the concept from The Art of Immutable Architecture as described in the previous answer. Immutability is represented as a key principle for building robust and scalable distributed systems. Okay, good. It's got that. There's a focus on event-driven architectures. Okay, good. Immutable records of what happened at certain times. Well, the time is not the important part, but let's continue. The book mentions using projections to represent state changes, which it probably got from that chapter. Good. Event sourcing is another key concept here. I think I do mention that in this chapter. Well, this is the analysis chapter. I'm not sure that I do mention event sourcing in this one. So it might have inferred that from its own knowledge. Separation of concerns. Projection consistency is crucial for maintaining accurate views of system state. Yeah, it's true. Not part of analysis. Yeah, it seems to be kind of veering off of the context and really just talking about related ideas. Adapters, gateways, translate between mutable and immutable models. I talk about those kind of adapters later in the book. But all right, so now it's finished thinking and it's actually answering the question. So, yeah, then there's all the things that we just talked about, but summarized in 2 bullets each. Okay, so a little bit more constrained, but still not completely constrained to this set of knowledge. It's still pulling in knowledge that I would like it to replace, or at the very least de-emphasize. Let's see. Yeah, that's conclusion is not too bad.
Powerful framework for building resilient systems.
Also presents challenges in design, implementation, monitoring that require thoughtful consideration. I don't talk about monitoring at all. So that is pulled from related context. It might be attaching the idea of immutability to immutable infrastructure, to DevOps, to monitoring and observability that way. Or I might just say software architecture, and then software architecture, we always talk about observability. So maybe, I don't know. So the thing that I really want this to do is to help me model the system. Remember the domain, or the system prompt started with a domain expert is asking you for help modeling their business process. Ask them questions about their domain. So it might be that those instructions got lost in all this context, but it so far hasn't asked me any questions.
We can ask you.
Yeah.
Can you give an example model
Yeah.
for what, for student registering for courses?
Okay. So it's
The answer can only be text, or can, for example, also be markup.
This is
and can contain graphics.
Yeah, this is capable of producing markup. So
ASCII graphics from long ago.
Yeah. Let's ask it to draw a diagram and see. So in the system prompt, I'm using dot markup in order to draw diagrams. It might actually do ASCII art for it. Yeah.
Yeah, it looks like he read the chapter.
Yep. So it is reasoning through some of the consequences of these design decisions, potential challenges, ensure all necessary information is captured without redundancy, handling mutable states through new facts rather than updates, linking related events correctly to maintain the historical record. Okay. Yeah. I mean, those are all things. Their differences, they themselves are not quite challenges. Challenges are things like ensuring that that a student has enrolled once and only once. If that's an important thing, the historical model itself won't do that. Okay. Student registration status, current status. If it had read the book on state machines, or the chapter on state machines, or state transition diagrams, or whatever I called it, it would know, okay, you don't put status into the facts. There's status all over this place. So I do believe that in the analysis chapter, I talk, at least in passing, about using a specification in order to determine the current status of something. But of course, I go into that in much detail in a later chapter. Okay. So we asked it to generate a model, and it's got I would say it's got the fact types in the field, so it passed that test. So draw a diagram. Let's see what it decides to do with that.
Then it answers, cannot find a pencil.
Yeah, this part of the think is probably going to be pretty interesting. I need to figure out how to draw a diagram. Where's my pencil? Give me something to write on, man. All right, so the model emphasizes three main constraints. Explanation also mentions two types of projections, aggregates and iterations. Aggregates and iterations, those ideas of projections come from different related systems. Domain-driven design, I don't remember iterations being in domain-driven design. What does it say about iterations? I'm curious here. Aggregates are cumulative functions. Iterations involve lists. Oh, okay. Those are okay. There, it's talking about the functional aspect of event sourcing. So that's, I think, where those things come from. Right. So it is finished thinking. So finally, I should include a note explaining that this is a conceptual diagram to help visualize the model without getting bogged down in technical specifics or implementation details. Good. Yes, you should say that. So here are the core concepts, projections that brought that. Cumulative functions like sum, standard deviation, max. Okay, yeah, that's stream processing or event sourcing. Yeah. Okay, but no diagram. It says this diagram provides a high-level overview, but there's no diagram.
Where is the diagram?
Let's see if it's able to do that.
You give it a hint.
And if the hint works, then the hint goes into the system prompt. So yeah, the user doesn't need to know to give it that hint. So yeah, I've noticed that when it does the thinking, it's first let me understand. So that's a good starting point. So it needs to identify the main components from the text. Well, you said aggregates and iterations. Yeah, deterministic sorting, creation order, node synchronization. Yeah, I think it's deviating a bit from. These are the tools that that historical modeling gives you. All right. So now it's starting to draw some arrows. So it knows what. Yeah, here we go. Here's the simplified graph viz diagram representing the concepts discussed. So it's inside of triple tick dot. It's a digraph. Then the nodes that it puts in there are projections, aggregates, iterations. Yeah. I'm kind of curious what this diagram looks like. Let's go ahead and see if we can run it through the tool and find out. So let me copy that. Go back to Visual Studio Code. Paste that in and
show it.
Yeah, let's see if you. Oh, actually, I don't want the triple ticks because I want this to know that it's graph viz. There we go. And then give me a preview. Where's the preview button? Preview graph viz. There we go. Okay. So that's what it came up with. Examples of aggregates are sum and max, iterations, deterministic sorting, creation order, table list. These are. Yeah, this is definitely not a model of the domain. So let's see if we can put it back on the right track. A graph of the domain facts So what were some of the domain facts so we can kind of remind it? So yeah, here we've got student admission is one of those, course offering, student registration. Okay. Yeah, so that should say, all right, pull that from the context. That's what we're talking about.
Mm-hmm.
Yeah, this idea of reasoning, I'm not really a fan of that word to describe what these things do. I mean, what they do here is to generate something that's reasonable.
Mm-hmm.
But even the idea of thinking before generating a result instead of just going straight at the result, which is what they call the reasoning step, that's still generating a plan using a template of plans. So plans tend to look like this. Plans start with, I'm trying to figure out, I need to understand. Okay, plans start with understanding, and then they go on to gathering information. So I also remember, blah, blah, blah. So you basically say, this is a template for a plan. So generate something that looks reasonable. Oh, here we go. We've got ASCII art. That's awesome. But something that looks like a plan is not necessarily a good plan. It just looks like a plan. So, yeah, calling that reasoning is a bit of a stretch. It's kind of like country music lyrics. So in a country song, they say something that rhymes and it sounds good, and they sell it as if it were life advice, and it's often really bad advice. One of my favorite examples is, you've got to stand for something or you'll fall for anything. Wow, that just fits. That is a great phrase, but that's not good advice. That's bringing two completely different ideas together, holding a position and being gullible. So those two are not related. So yeah, this is just country music reasoning. So I need to understand what each of these domain facts entails. It looks like it doesn't remember the previous design that it came up with. So it's likely this involves a student applying for admission in an institution. Well, yes, we just talked about that. Mm-hmm. So maybe the context window of this model, or at least the 32 billion parameter version, is too small. I also remember that each fact is an entity with its own attributes. Yeah, and I think it came up with brand new attributes this time around.
Because if every time he changes or he forgets, then it's quite useless.
Mm-hmm.
Even like it works today of reading your book.
Mm-hmm.
If it doesn't remember what it said last time.
Yeah, and this is all in the same session, so it's retaining that context as it moves along. But okay, so we've got a diagram, student admission, course offering, student registration. Okay, so if I interpret this as a historical model, which it should be thinking about this as a historical model, the arrows are pointing to predecessors. So this is saying a student registers for a course offering, which is one definition of registration. Actually, I think that is the definition that I use in my models as well, as opposed to enrollment, where you enroll in the university. So first, this student is admitted, so that's the enrollment process. And then a course is offered. Well, the course offering excuse me, the course offering doesn't care about the student admission. The course that would have been offered had that student not been admitted. Those facts are not causally related, so there shouldn't be any error between them at all. But then student registration should point to the student admission and the course offering, both. So the student must be admitted before they can register for a course, and that course must be offered before the student can register for it. So, yeah, the relationship is one to many. The cardinality of the relationship is not nearly as important as the causality. So, yeah, it is not thinking about this as a historical model. Yeah, so in the prompt, I specifically listed these three examples. Yeah, please generate including student admission, course offering, student registration. I came up with those three examples. In order to, what I wanted to do was remind it of the previous context, but instead it just started building fresh from those three. So that's why it doesn't include anything else. Yeah. So yeah, I think this particular experiment, we can say we've learned from it. This is not yet a useful tool. I think the next experiment that I want to run is to actually give it some Jinaga code. Then see, okay, assume that you're talking to a developer. They do have experience in C#. Now, just help them to write a specification.
There's no way here in this one to tell it to keep old context.
Yeah, I would if I.
Because
Yeah.
it's amazing that it doesn't remember about. It should be for the session.
Mm-hmm. Yeah, there is a. If I go to the Llama GitHub repository, this is where you can find all the information about controlling models with Ollama. And there's one document in here. Well, I'm trying to remember what it was called so I can search for it. But there was a... oh, okay. Create model file. There we go. Come on. So with these model files, and this is basically what... goodness. You can do it. This is how I learned how to do this in the first place. But yeah, these things here are model files. Like, there we go. So in addition to from and system, there are some other options. There it is. Okay. So you can set parameters. And so with the parameters, these are some of the common parameters that, so Ollama has the code that runs a model, and then when you download the model, it's the weights. So the code that runs the model has these parameters built into it, but I believe the model that you download has defaults for various parameters. So if you don't override them, then you get those defaults. So we can do things like set the num context, the size of the context window. Oh, this is, the default is 2048 tokens. Now, since DeepSeek R1 is very chatty, it might just be blowing out that context window on one or two responses. So that might be the thing to do. So bump up num context and then see if it can remember longer. Let's see. But yeah, so we can play around with some of these, see see what it can do. Also, probably work on giving it a simpler task. So I think code is going to be a simpler task than working with a domain expert to try to figure out a model. Um, yeah, for that, yeah, you really need a consultant with those skills of asking good questions, and so improving. There we go. I had to get that in. Um, so uh, so maybe I'm asking a bit too much. So we can
Because for the
start
moment,
from there.
it's not like building the model and asking questions, not at all.
Yeah, it's not. Yeah. So all that reminds me. Let me show you real quick the. I'm gonna run DeepSeek R1. Let's start with let's just do the small one, um, and let me show you the reasoning problem that I gave it, which ended in hilarity. So yeah, I am playing a variant of chess. Um, pieces can move off the edge of the board. They reappear from the other side, as if the board were on a torus. This is also similar to the Asteroids video game. What is the best strategy for black? So, so this is a very difficult problem for this kind of reasoning, because it's not really doing spatial or mathematical reasoning. It's doing textual reasoning, so it's trying to come up with a plan that looks like looks like a plan. And this is the one that, hey, well, actually, but perhaps, and so it keeps on coming back. And so I think the way that this is set up to come up with a plan is to derive a plan, evaluate its confidence in how well that plan will answer the problem, and if it's not confident, go back. So based on that hypothesis, that explains this behavior, that it's never getting anywhere close to something that will reasonably answer the problem. And the what's so challenging here is that the answer is not in the text. The answer here is that you literally have to visualize the board and move the pieces off the edge, see where they come back. I didn't state in this prompt that you start at the starting position. I just left that to be assumed. But yeah, if you visualize the starting position and go through that exercise, then you quickly learn something really profound about this variant of the game. So yeah. Yeah, here it stopped with boxed, which I've seen it do that. I think that is supposed to put things in. That's kind of markdown for putting things in some kind of pull quote area, or yeah. I think that's what it was designed to do. But yeah, the key idea in a 8x8 toroidal chessboard: each piece has equal access to all parts of the board because there are no edges. The symmetry means the advantage. One player might. Thus, black should adopt a mirroring strategy. Yeah. Okay. So I'm going to try to guide it to the answer. So, given the standard opening, are there any captures that white can make on their first move? Yeah, this is the thing that you have to realize when you set up the initial
Mm.
position. Oh, I can wrap from the top to the bottom or the bottom to the top in the case of white making their first move. All of the white pieces are just right next to all of the black pieces. So at least it knows where the white pieces are. Uh,
Mm.
Wait a minute. It messed that up too. King on D. Wait. D is the queen's column, not the king's column. The king is on the E. Rook at E8. What? Okay. So yeah, it is completely lost. Um, but yeah, what you have to reason through is the fact that there are four pieces that white could use to capture the black king on the first move. And so it's not even a valid opening position. Uh,
Mm.
but yeah, it comes down. Like, no, white cannot capture anything on the first move from the starting position. Um, yeah, yeah, because they have not moved any pawns, and knights can jump over pawns, but there's nothing in reach. And it's not reasoning through the toroidal nature of the board. So yeah, I gave it a. And by the way, I learned this particular problem. Um, Goodness, Sean. What's his name? He's a yeah, physicist. Yeah, a philosopher. Sean Carroll. Yeah,
Mm.
he's got a podcast where when ChatGPT first came out, he was asking it all sorts of interesting questions. And even though Sean Carroll is a famous person, he's got a Wikipedia page and everything. He asked ChatGPT about him. It got the fact that he was a physicist right, but then made up a whole bunch of
Mm.
other things. Um, and then he posed this problem, and he posed a similar logic puzzle, not quite this hard. And of course, ChatGPT wasn't able to reason through it. Now that we've got reasoning models, they should be able to do better at these things, but they're
Mm.
not really reasoning.
Now, if we go back to an historical modeling,
Mm-hmm.
and we would, for example, say, I would like to make a model back like the university and the students, um, help me or ask me the right questions to be able to construct the model, something in that sense.
Yeah. And just to try out different things, I went back to the Llama uh, version. So yeah, this is without reasoning. This is just text generation. What type of information do you want the model to capture? User interactions and roles, system components. Yeah. I want to focus on domain concepts as represented as historical facts. Okay, so let's dive deeper into domain concepts.
Trying to
Yeah,
avoid.
yeah, yeah, and now it's no
No,
longer asking a question at all.
no, it's yeah. Um, no, it's not doing what we want.
No. Oh well. So yeah, we'll keep playing with it. So
Because
yeah,
the purpose is that this guides a developer to get a
yeah,
problem solved with historical modeling.
yeah. The vision that I see for this is that
Mm.
that we've got a canvas that the user can access. So similar to how I use GraphViz in order to quickly add facts just by typing things in and then they appear.
Mm.
Um, so um, so that kind of a canvas, but it's the AI that's in charge of actually typing in the text, and then so there's this ongoing conversation. They're seeing the model evolve during the conversation, and it's asking questions and iterating to a good model, and then telling you the consequences of your decisions. So, because
Mm-hmm.
we modeled um, we modeled registration as the course offering is related to registration, like we saw in the previous one. That means that every time a student registers, we're going to offer that student a course. Is that what we mean? So say, oh, wait, no, the offerings exist before the or after or whatever. Um, so reason through those consequences, and then update the model accordingly, uh, and then basically shift gears, or maybe even have something that you can kind of go back and forth between to the implementation side. And so now, hey, we're talking about what user interfaces do we want this to have? So, okay, I want a mobile
Mm-hmm.
application where a student can see their current semester's course schedule. So you can just pull it up, know where they're supposed to go. That's uh, that's one of the features, and um, and so then it should be able to generate code based on those. One of the things that I want it to be able to do is generate specifications. That seems to be the most challenging part of using Jinaga. Is this is what I want to appear, and I need to reason through how to write that in LINQ and in order to create a specification. And the tools like ChatGPT know, or really like GitHub Copilot, I would say, they know LINQ. They don't know the Jinaga variant of LINQ, and so they give you all of the LINQ options. And so I would like it to be constrained to this is just Jinaga LINQ, and so I know your model. I know the view that you're going after. We're going to iterate on this specification, and then one of the advantages of using a language model is that it can generate example data. That's going to be a great feature of this. So you come up with a model, it generates some example data, and then we come up with specifications, and it runs those specifications, shows you the results. And you're like, no, it should be like this. Make those changes.
So
Compile the app.
to avoid that it goes outside of Jinaga, you could say use the link syntax,
Mm-hmm.
but limited to what is allowed in Jinaga.
Yeah.
And they're based on your website, on the docs, perhaps it could do a good job.
What I've found experimenting that way is that it's like telling a person not to think about elephants. It starts to think about all the things it's not supposed to think about.
Yeah.
So it's really hard to get it to ignore parts of its training set. So I think that one of the techniques I need to practice with is refinement. So take an existing model and then give it some desired output, and then basically build a new model. Tweak the weights in order to get it to produce that kind of output. So I think with that technique, I can get it to focus its attention more on the subset that I want it to focus on.
But I think that the specifications, that's still quite mathematic.
Yeah.
but the guiding towards a model
Mm-hmm.
where it asks the right questions, where it informs you about possible consequences, where it gives you hints,
Mm-hmm.
alternatives, that looks me much more complicated.
Yeah. Yeah, and
Um,
that's a language problem. So you would think that the language models would be better at that problem versus,
mm,
like you said, the specifications are a math problem, and they're not really good at math problems. Um, so maybe there's maybe there's a set of models. What's the term that they use for this in so it's a a set of experts there's another term that is used besides set of experts, but the idea is that you've got different models that are refined for different purposes. So this one is refined for the specification language, and then that one is refined for for building a historical model based on a domain. So then put those together, and basically you build out a wider neural network where the first few layers are selecting which expert to give the prompt to.
And then you get a conflict between the two.
Yeah, because it's not a binary digital selection. It's like send more weight to this one and less weight to that one, and so yeah. And then toward the end, it's like take these and synthesize them into something reasonable, which I think is probably a good approach worth exploring. Then there's also the more agentic approach of each model is refined and as a separate agent within the system. So you start with this agent and you say develop a plan, and this agent takes that input and then comes up with a plan that knows which other agents to send it to. Basically, you tell it what the organization looks like. You are the president of the organization. You're going to delegate. Presidents of organizations tend not to delegate. They're too busy making high level decisions. But use those terms, whatever. And then it delegates different tasks to different, and then you take those, chop them out and say, all right, you've got these sets of tasks. Do what you can with what you know. And then something at the end to pull them all together. So that might be an approach as well. Yeah, but just throwing a model at it, not good enough.
We want it to be human, almost react as a human. But
I don't know. Do we? Humans are weird.
Then you get ego problems.
Yeah.
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 No.
We want good outcomes. That's what we want. But yeah. So that's what I've been playing with.
Yeah, but anyway, it does amazing things. If you look last time with a Copilot, the way it could come up with solutions,
Yeah.
It's amazing. But here the problem is much wider, and it drifts away from the target.
Yep. Yep. So have to figure out how to make it not drift away.
Development of these things is going fast, so
Yes,
in a couple of months we might have models that are suitable.
Yeah, and that's the real innovation of DeepSeek is it demonstrated that that you can build much smaller models that can do, at least look like they can do the things that the larger models can do. So cut down the cost of training, cut down the the cost of running them. I could not run O1 on this laptop, but O1 has far more than 32 billion parameters. In fact, the DeepSeek that you can use through the app, that's the 407 billion, I think is the number, parameter version of the model. So it's it's an order of magnitude bigger than the one that I can run. But still, you could get a decent set of servers running in your data center and run that 407 billion model, parameter model. You cannot run O1. Maybe because it's too big, but certainly because OpenAI doesn't share it with anybody. It's not an open weight model. So that's the research process.
One day we will get there.
Yeah. All right. So yeah, I'm going to get back to building out the example. So identity might be the next part of it, or or I might, start building the example by having a service that simulates incoming curriculum, and then something that does the Elasticsearch index, kind of show that happening, put that into Docker Compose. I think that's the next part that I want to do there. So, yeah, we'll see. Do I do that without the extra security layer, or do I build the security layer and then do that? Well, either way, it'll come together.
I think the search process would be the security layer for the moment. Is not for the demonstrations. It's not that important.
Yeah.
But the Elastic engine would be nice to see how that can give flexible answers within a Jinaga framework.
Yeah, I think so. So, yeah, I think that's what I'll focus on for next week.
Okay. See you next week then, Michael.
Yes, indeed.
Okay, and bye-bye artificial intelligence.
For now.
We have to be nice to them.
Yes. This is the first thing that actually got my laptop warm.
Okay, yeah. Okay, Michael. See you next week then.
All right. See you.
Bye-bye.
Bye.